A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earth shake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not 1, not 2, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something that can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas Fault Line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas Fault, we'll see how much more dangerous the Cascadia Zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas Fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
Around 3 to 200 million years ago, all the continents were stuck together as one big landmass. Over time, they moved apart and formed the continents we have today. That giant landmass was called Pangaea, and the Earth looked very different back then. Which begs the question, what would our life be like if that split never occurred? Well, let's find out. In simple words, tectonic plates are big chunks of the Earth's outer shell. Our planet is like a puzzle of landmass, and these plates are the pieces. Since the Earth is so incredibly hot inside, its heat influences the rocky ground above the core. Slightly melted rocks start floating in the ocean of scorched magma. This movement creates the tectonic plates, and they're always moving. just really slowly, which is why we don't notice it. Their movement has been a fundamental force shaping the Earth's surface, climate, and the evolution of life over millions of years. For example, when two plates bump into each other, one might go under the other. Or they might slide past each other. Sometimes they pull apart. All these movements create things like earthquakes and volcanoes. And when plates push against each other, it can make the land go up, creating mountains. So, the big mountain ranges on Earth like the Himalayas formed because tectonic plates were pushing into each other. Now, here's the thing with Pangaea. In a supercontinent, all tectonic plates are united, and they don't really move. Well, at least not a lot like they do now. So if Pangaea remained intact for billions of years, everything in our world would look completely different. For example, we wouldn't have many mountain ranges anymore. No Alps, Himalayas, and Andes. What a nightmare that would be for ski lovers. But there's an upside to that too. No continental drift means much less disasters in our world. All our earthquakes, tsunamis, and volcanic eruptions would be much rarer and calmer, or might not occur at all. However, hurricanes would keep existing, and they could be crazy strong. With Pangaea being one huge lump of land, the rest of the world will be water stretching from the west to east. That's just a free water slide for a hurricane. Please feel free to build up in intensity without anything to bump into. So once it finally reaches us, prepare for Category 5 or even stronger hurricanes or tornadoes. They'd be regular visitors too. And if you decided to live in eastern Pangaea, yep, you're doomed. The way the continents are arranged also affects how the oceans move and the weather behaves. In Pangaea, the climate would be very different across the globe. The middle of our supercontinent would be super weird. Right in the center, we'd have a huge dry desert. But there would also be dense, cool rainforests along the borders of this desert. Why? Because Pangaea is so massive and rain from the ocean wouldn't reach far enough inland, so it would be stacking up around the edge. This would make some parts of the land not so great for anything. Rain and water would wear down the land, flattening hills and carrying away soil over a long time. Eventually, Pangaea might even shrink and disappear underwater. Closer to the edges of Pangaea, the weather might be more mild or tropical. Up north, it would be warmer than it is now. And finally, we'd have some understanding of seasons, but we'd have no idea that it becomes harder for you to breathe as you go higher. So, how would all this affect living things? Well, bad. Pangaea would be awful for the variety of life on Earth. History shows that having separate pieces of land is very important for life. It was a big reason why new kinds of species appeared. For example, Madagascar, an island that broke off from Pangaea, was isolated for millions of years, which is why it has many plants and animals not found anywhere else. Fewer isolated lands like Madagascar and Australia mean less cool and unique plants and animals. The climate problem doesn't go away either. Almost all Pangaea would be hot and dry inside, but it wouldn't be all too boring. There would still be some environments for animals to live in. Reptiles like dinosaurs might do well in this kind of climate. That's one reason why dinosaurs thrived when the whole world was one big landmass before mammals came around. Also, this might push for the development of creatures that can live in water. They'd be more diverse and bigger in size. So basically, Pangaea is a master of creating Earth as dangerous for humans as possible. With all this in mind, let's finally see how humanity's doing, assuming that we survived and evolved. First of all, where would your country be located? In theory, you could take a road trip from Brazil to Canada, because they'd be part of the same huge landmass. North America would be right here, and Europe would be just east of it. Most of Asia would be up north, and Antarctica would stay down south. Australia would still be in the middle of nowhere. A literal Antarctica would be closer to everyone than Australia. That's assuming that countries stayed the same. And hey, cool news! all our modern countries might not exist at all. Okay, that didn't sound as good as intended. More precisely, the countries would have completely different boundaries, and the world would be much more peaceful and united. Let's see. First, we'd form some tribes. But since we would share the land, we'd have to compromise. We can't all have the only coast or only inland regions. Each tribe would probably get a fair piece of the land so that everyone could meet in the middle to settle problems or make trade agreements. As tribes got bigger, people would move to new lands, separated by deserts and forests, forming their own nations. The hunter-gatherer era might take some more time, since we have fewer animals and plants. If we started hunting, we'd probably wipe out all the big animals pretty quickly, except for the ones we could potentially domesticate. Imagine having dinosaurs as pets! But the whole supercontinent would quickly enter the agricultural era, because whatever technologies we discover, we'd share them with each other right away. The main difference would be that during our age of exploration, there would be mostly small, isolated islands to discover. Travel and trade would be easier too. Cultures would be less distant from each other compared to our world. For example, right now, Native American culture is very different from Pacific Island culture because they've been separated by water for a long time. But on Pangaea, cultures might form a continuous line from the southern tip to the northern tip, which means all cultures would be very closely related. And that wouldn't be the only similarity. Our appearances would be very much alike as well. Since Earth is still tilted on its axis, the very north and south will stay cooler. So even though some people would still have white skin and blonde hair, in general, everyone would still have less melanin. Around the central part where the sun is always shining, most people will still have dark or tanned skin. This could create a more similar world where people could see themselves as global citizens and Earthlings. The sad part is, we probably wouldn't be as motivated for technological progress as we are now. All the land is already known. There's no need to explore. The weather is mostly good and warm. The crops are growing well, the neighbors are hopefully peaceful, which is why humans would be fine with things as they are. We'd probably stick to basic tools and science. Of course, we're naturally curious creatures, so we'd still have some progress. It just would be very slow compared to our world. What sounds boring for some might sound awesome for us. Our life would be less exciting, but we'd be more united and peaceful. Maybe, in a world like that, we learn to treat each other with more kindness and love. But we can only imagine.
You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive. And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. That's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity times 2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes. making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6, otherwise bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean, a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes. At this very moment, scientists are getting ready to explore the Earth's deepest layers, where temperatures are insanely high and the pressure is crushing. It might sound like a plot from Journey to the Center of the Earth, but it's for real. By 2026, the Krafla Magma Testbed Project plans to drill into an active volcano in Iceland. Their goal is to search for magma. Yep, that boiling molten rock that we often associate with destruction. It is a high-risk mission and a huge technical challenge, but the payoff can transform our future. This isn't our first attempt to journey to the center of the Earth. Back in 1959, Hawaii witnessed a breathtaking spectacle as red-hot lava violently erupted from 400-foot Kilauea Iki crater. Over the next 5 weeks, lava fountains erupted in 17 major bursts, with the tallest reaching a record 1,900 feet. This spectacular and terrifying event left behind a glowing lava lake in the crater. A few months after the eruption, the lava began cooling and forming crusts. That was a perfect chance for scientists to drill into that lake, see what was going on beneath it, and collect data about the magma reservoir. Over the next 2 decades, they kept coming back, digging a little deeper each time. By 1979, they managed to get 173 feet down. Up to that point, it was the closest we had ever come to an actual magma chamber. And by that, I mean the underground pool where magma sits before eventually rising to the surface and causing a volcanic eruption. Decades later, the dream of reaching magma finally became a reality. We are now in Iceland in the year 2009. The Iceland Deep Drilling Project has just kicked off. Their goal is to transform the Earth's inner heat into clean energy for everyday needs, such as heating homes and supplying hot water for baths. You see, using heat from the Earth's interior to make energy isn't new, but it usually comes from hot water underground, not directly from a freaking scorching magma chamber. That's why the Iceland Deep Drilling Project was such a big deal. Magma could be a clean, renewable power source. And since it's hotter than the geothermal energy we normally use, it could generate a lot more power. Iceland is a natural choice for this kind of project. Known as the land of fire and ice, this country is home to some of the most active volcanoes on the planet. One of the most popular ones is Krafla, a volcanic caldera of about 6 miles in diameter, located north of the island. So, the initial plan of the Iceland Deep Drilling Project was to go there and excavate 13,000 feet deep. But something unexpected happened. When they were only 6,900 feet down, the drill hit magma. Wow! On one hand, it was exciting, because, well, we finally found it. And just like that, Krafla became the first place in the world where we know exactly where magma is. But on the other hand, their equipment wasn't prepared or built for it, and the molten rock basically corroded their infrastructure, bringing the project to an end. Instead of being a failure, this accidental discovery gave us a ton of valuable data. We realized that, with the right equipment, drilling in such extreme heat is definitely possible. Scientists found that these underground molten pools can in fact produce a significant amount of geothermal energy. And most importantly, we learned exactly where the magma was. That brings us to the current Krafla Magma Testbed project. This scientific program aims to create the world's first magma center. The idea is to set up a base where scientists can safely work with magma and have all the necessary infrastructure to run experiments on volcanic risks and geothermal energy. So that's like the basic idea. But their real plan is to return to Krafla, drill back into it, and create a gateway to the magma chamber. The goal is to understand its potential for generating energy, study its properties, and see if we can use it safely and efficiently. If they pull this off, it could provide a nearly endless source of geothermal energy for Iceland's homes and buildings. Even though magma is incredibly hot, reaching over 2,000 degrees Fahrenheit, experts say it is safe to take energy from it and believe the process won't trigger another volcanic eruption in the country. They're so sure about this, partly thanks to the Iceland Deep Drilling Project. But this whole process isn't like drilling for oil or gas. It's way more challenging and risky. Magma is not just extremely hot, it's molten rock, which can wreck equipment and pose serious safety issues. Right now, the Krafla Magma Testbed project is in its early stages. Scientists and engineers are working hard to develop the tech needed to drill into magma safely. They're testing new drilling techniques, creating heat-resistant materials, and running simulations to figure out what happens when you actually drill into a magma chamber. They hope that by 2026 they will be ready for the next step, which means going back to Krafla and drilling all the way down towards the magma chamber. It might take 2 months to reach it. Their plan is to drill a single hole that will go right into the magma body and hopefully keep the equipment running there for many years. If they succeed, scientists also plan to add special sensors down there to measure and monitor pressure. This could help predict eruptions better and prevent disasters, like what happened with Mount St. Helens in the United States. In 1980, this volcano erupted, causing massive destruction and claiming over 50 lives. The eruption was so intense that it completely blacked out sunlight in Spokane, Washington, which is about 250 miles away. While that sounds terrifying, it's nothing compared to a super eruption, like the one that happened over 70,000 years ago at Toba volcano in Indonesia. This disaster was about 1,000 times more powerful than Mount St. Helens. Toba is just one of the 20 supervolcanoes on Earth. A supervolcano is what people call a volcano that can produce an eruption of magnitude 8. These eruptions, known as super eruptions, are the largest and most explosive ones. They could have global consequences by affecting the climate and causing widespread destruction. For example, if Yellowstone had a super eruption today, the surrounding states of Wyoming, Idaho, and Montana would be directly affected. They could be hit by hot avalanches of volcanic ash, gases, and rocks that might reach temperatures of up to 932 degrees Fahrenheit and speeds of over 180 miles per hour. This nightmarish scenario is a real possibility, but predicting when it might happen is almost impossible. Volcanoes don't follow a precise schedule, so it is hard to predict when a supervolcano will erupt next. That is also why the Krafla Magma Testbed is so crucial. By examining a volcano's activity from within, scientists could potentially predict eruptions with much more accuracy. As you might have guessed, drilling into magma is definitely uncharted territory, but the potential benefits are huge. Besides providing a clean energy source and making people who live near volcanoes feel safer, this project might also help us learn more about what is beyond Earth. Yep, it could lead us to breakthroughs in space exploration, helping us understand how other rocky planets and moons formed their crust, just like Jupiter's moon Io, which is the most volcanically active world in our solar system. In the end, the Krafla Magma Testbed project is more than just an experiment. It is a bold vision for the future of energy. It's about pushing the boundaries of science and engineering, taking risks, and dreaming big. So we should definitely keep an eye on Krafla, because this adventure into the fiery depths of our planet could end up changing our future. Suppose everyone in the world wants to do this, and countries started investing billions of dollars in this project. In that case, we can colonize the ocean floor. The question is, why would we need this? For the same reason we're going to colonize Mars, to save Earth from overpopulation. Why do we need to move to the red planet in the near future if we can live underwater? It'll be cheaper, safer, and most importantly, not far from our home. You don't need to stay in cryocapsules for years to wake up hundreds of millions of miles away from your planet. It's much easier to take an elevator down to the underwater city, hang out there, and enjoy the views of marine nature. Besides, staying on Mars will surely cause severe mental problems for people. Panic, stress, and the realization that you can't return to your home whenever you want can put serious pressure on your mind. It's better to live under millions of tons of salt water, and the reason why we have to do this is a need for more resources. There are about 8 billion people on Earth right now. Some experts think that when the number reaches 10 billion, the world will begin to run out of food, fresh water, and fuel. Agriculture and other industries simply won't be able to develop so quickly. Resources will be depleted, and people will have to do something to survive. The colonization of the ocean is an ideal solution to the problem. Firstly, we have very little information about the ocean. We've studied space much better than the ocean on our planet. Most likely, vast reserves of fuel are hidden under the seabed. Secondly, we will be able to reduce the load on our planet by about 50% if we move to live in the ocean. Thirdly, there will be no problems with logistics. Delivering food, necessary equipment, and construction materials will take hours, and if something breaks along the way, you can return to the surface and try to deliver it again. Sending things to Mars would be much more complex and expensive. Imagine that halfway there, millions of miles away from Earth, something breaks down on the spaceship with provisions. Then you'll have to wait for many years for the next delivery. But the main reason for ocean colonization is protection from disasters and natural cataclysms. Volcanic eruptions, radioactive winter, earthquakes, tornadoes, and floods. We can easily wait out any disaster underwater. Yeah, there are volcanoes on the ocean floor too, but the consequences of their eruptions are not so dramatic. The water immediately cools the lava and prevents ash from spreading. We will never experience the consequences of fire again. No burning forests and polluted air. And speaking about the air, there's a lot of oxygen in the ocean. More than half of the oxygen reserves on the planet are replenished by the sea, thanks to algae and phytoplankton. So don't worry, we'll be able to breathe deeply. The main thing is to figure out how to do it underwater. When humanity decides to take such a global step and begins to colonize the ocean, we will first have to adapt our bodies to high pressures. There's such a thing called saturation diving. Before descending into the depths, you must inhale compressed air. The nitrogen and oxygen quickly dissolve in your blood and exert pressure on your body from the inside. At the same time, the water pushes on it from the outside. In simple terms, your body is in balance and you don't feel bad. Divers use this method when exploring the seabed at great depths. Therefore, when people begin to colonize the ocean, they will dive there wearing cylinders with compressed air and an oxygen mask. The main rule is to surface slowly. You need to wait until the compressed air completely dissipates inside your body. If this isn't done and you rise to the surface, then you will feel intense pressure from the inside. Nitrogen will start acting in your veins like soda bubbles when you shake a can with the drink. After this adaptation, we will start building cities, roads, and stations that will transfer people to dry land and back. It shouldn't be too difficult because we already have the technologies needed for the underwater lifestyle. Welcome to the Aquarius Reef Base, located at the bottom of the Florida Keys Marine Reserve. This is a small laboratory where 6 people can live for 10 days. Scientists working there study coral reefs, marine plants, and fish. The lab doesn't look modern. It resembles a sunken, rusty bathyscaphe overgrown with shells and other underwater stuff. To create buildings with more beautiful designs, people will need new technologies for underwater construction. So let's imagine that global colonization has begun. Engineers use durable stainless metals and other materials capable of withstanding high pressure. With the help of freight elevators, people lower everything needed for large-scale construction to the bottom. Stations with such elevators appear in all the seas and oceans. Workers build huge underwater constructions on dry land. Then, large ships deliver them to the stations. From there, they descend to the bottom, where scuba divers and robots set these houses on the ocean floor. Every building is like a giant submarine with lots of apartments. They look ordinary from the inside, except for the underwater view from the window. To reduce waste emissions, engineers build huge capsules in every city, where garbage is destroyed by high water pressure. People try to live closer to the shore because they want to spend less time commuting. This causes severe pollution in coastal areas. Builders set up communication between the stations and land by creating vacuum tunnels with high-speed trains inside. In simple words, this is an underwater subway, only much faster than the one on dry land. From now on, people move farther from the shore to live in cleaner water. Humanity begins to make daily life in underwater cities more comfortable when the main construction is over. Scientists create filters that can quickly purify seawater. Now, everyone has a faucet that takes water directly from the ocean and turns it into fresh water. Also, constructors put in air filters capable of extracting oxygen from the water. Electricians create underwater mills to generate energy. To leave home, a person must put on a diving suit and cylinders with compressed air and exit through an airlock. People swim between buildings and talk to one another using radio communication. For faster movement, car companies produce small bathyscuffs with locked cabins and powerful propeller systems. Over time, engineers create large domes where you can walk and breathe fresh air, like on land. Global clothing brands develop fashionable diving suits and practical accessories for comfortable underwater movement. For example, you can attach a small heater to your clothes to not freeze while swimming. And you can also put on wider fins with engraved brand symbols. To make such a lifestyle as comfortable as possible, scientists and biologists create masks that work like gills and provide a person with oxygen extracted from the water. Constant exposure to high pressure changes people's physiology over time. In the water, we need to put more effort into moving. People who often leave their homes lose a lot of calories. They become slimmer and their muscles get stronger. Look at the Olympic swimming champions. Now, almost all underwater citizens have the same developed shape. Our body temperature is falling, and evolution slowly turns us into cold-blooded creatures. A lack of sunlight makes our skin paler, and we start resembling amphibians. We learn more about deep-sea creatures such as the giant squid and other monsters. Almost every month, scientists discover new species. But at the same time, many fish species disappear because of human activity in the ocean. The extraction of natural resources from under the seabed heavily pollutes the water. To reduce the load on the planet, people decide to colonize the sky. But this is a topic for another video. It was hot in the tropics, a type of heat unknown to the men aboard the Nina, the Pinta, and the Santa Maria ships led by Italian explorer Christopher Columbus. It had been months since these men left their home cities in Europe, and until then, Europe was all they knew. They were given a difficult and even dangerous task. Spain hired Columbus to find a new western route to Asia. They needed new routes for trading and buying spices, but it was far from a simple job. I mean, crossing the ocean never is. Little did those sailors know that their lives were about to change forever. "Land in sight!" someone must have shouted on board. But when they finally stepped on that new foreign land, they discovered they were not in Asia. They had landed in the Americas. You've probably heard this tale before. Historically speaking, Columbus arrived in the Americas in 1492. But what would have happened if Columbus's ship had faced a lethal storm in the Atlantic Ocean and had never made it to the new land? What would today's history look like? First things first, nobody discovered anything. When we say that the Americas were discovered, we're kind of ignoring the millions of people who already lived there. You see, the Americas were only discovered from Europe's point of view. Columbus would only have discovered something if when he got there, he was faced with acres and acres of empty land. But that was not the case at all. Second, Columbus was not the first explorer to land in the Americas. Believe it or not, the Vikings approached American shores in the 10th century. Their expeditions have been well documented and accepted by scholars. Here's what might have happened. Around the year 1000 CE, Viking explorer Leif Erikson sailed to a place called Vinland. Cute name, huh? It's now a region in Canada called Newfoundland. But his crew didn't stay too long. They arrived to find 10 Native Americans napping under their overturned canoes. They attempted some trade, but I'm guessing the Vikings weren't too friendly and the Americans didn't really like them. The Vikings' account of the encounter shows they felt outnumbered and menaced, so they sailed away back to their land. That makes sense, right? As I said earlier, there were millions of people living in the ginormous continent of the Americas. Any foreigner would be outnumbered there. Now take a look at what North America looked like before our buddy Chris got there. It was not divided into the normal states we're used to. And if Columbus had never arrived, the United States would probably never have been united to begin with. After all, there were hundreds of first Americans living in these lands, and they lived amongst their own tribes, quite different from the Europeans. It's not accurate to think that there were no political systems going on in the Americas before Europeans arrived. We just need to understand that they were different from what we're used to today. When Europeans arrived, they imported their belief systems with them, from religious beliefs and language systems to things as simple as clothing habits. If the Americas had developed on their own, maybe their sense of fashion would be completely different today. You see, Europeans had a developed sense of fashion by the time they arrived in the West. They wore things such as this and this. But those don't really work in the tropics, do they? For them, fashion had to do with showing a certain economic status, while in the Americas, that didn't exist. For Native Americans, clothing was mainly functional and related to the weather. In warmer climates, Native people would wear short-like cloths to cover their intimate parts. They would walk bare-chested and use shoes known as moccasins. Yes, similar to the moccasins you probably own. In colder climates, they would resort to using leather and fur parkas. Of course, there was always the special clothing used for ceremonial purposes. So I'm guessing that if Columbus never reached the Americas, brands such as the Gap, Hollister, and Forever 21 would have never existed. But we could live with that, couldn't we? Here's a wild thought. Let's say that by the 1700s, Native Americans had developed complex engineering skills. They built big boats, maybe a bit smaller in size than the traditional European ships, and decided to venture across the ocean. Let's say they were the ones who arrived on European shores, in places such as Spain and Portugal. They carried gifts and goods with them for trading, of course. This was also a common practice amongst them back home, known as potlatch. Sure, they were received with suspicion by the Europeans, who had only ever traded with Asia. But with this inverted encounter, a different type of relationship began between Native Americans and Europeans. Since Europeans didn't claim ownership of the Americas, the people from the so-called New Land weren't considered inferior to them. Actually, they stood side by side as equals, each one with their own power and set of knowledge. Native Americans taught Europeans a new type of ruling system, a more decentralized one. So modern-day structures of government would look really different. Maybe Europeans decided that 4 years was a long time for someone to hold decision power, so they implemented smaller and more frequent elections. Oh, and the landscape of European cities also changed a lot. Instead of huge statues made of copper and bronze showing men in ships on their way to the Americas, the Europeans built totem poles in honor of their alliances with first Americans. In terms of medical and medicinal knowledge, they had a lot to exchange about. While Europeans were making advances in traditional medicine, Americans had developed an impressive knowledge of herbs that could heal a series of things. Before they knew it, Europeans were selling different varieties of plants in their pharmaceutical establishments. They had one big barrier though: language. Since Europeans never arrived on American shores, they also never taught their language to Americans. So maybe in this scenario, both cultures brought in their best linguists and tried creating a new language from scratch. Something that could be comprehensible from both perspectives and that could encompass both of their worldviews. The implications of this on modern-day life would be really profound if you stop to think about it. Let's say that this newly created language involved some symbols and drawings in it. You see, Native Americans often told stories using symbols known as pictograms. They were quite literal sometimes. As you can see, a mountain was represented by, well, a mountain. It's crazy to think that this system of communication has been around for 5,000 years, since it was actually invented by the Sumerians. And hey, maybe even our laptop keyboards would come equipped with these symbols, and you could write more visually hybrid and fun emails than the ones you write today. The American landscape would have also changed. You see, if neither Columbus nor any of the other European dudes that went after him reached the so-called New Land, Central and Latin American cities would look completely different than they do today. Maybe the bustling empires of the time, such as the Inca, the Maya, and the Aztec, would have grown immensely. To be fair, they were already pretty big by the time Europeans got there. Some pre-Columbian Maya cities were as big as medieval London and Paris in terms of population. But oh my, the Mayan Empire would have grown so much that it could have spread out all over of Central America. They could have developed their pyramid building craft up to the point that they managed to build an even larger pyramid than the Giza pyramid in Egypt. So tourists would come from all over the world to visit. And in South America, let's just say the region could have turned into a huge forest, bigger than the Amazon. The Inca could have spread through the Andes and then into the mainland. Places such as Brazil and Argentina never existed. But in their place, there would have been dreamy tropical settlements, which would have become a worldwide reference in sustainable living.
So, how long would it take to drain all the water out of the ocean? Any guesses? Well, the water would be rushing out at almost a mile per second. Imagine if we had a drain that was only 2 inches wide. With a drain that size, we'd be able to drain about 105 cubic feet of water every second. But here's where things get mind-blowing. The oceans hold 332,500,000 cubic miles of water. So, if we were to drain it at a rate of 105 cubic feet per second, it would take us, well, get ready to look at the screen. I can't even pronounce this. That many seconds to completely drain the ocean. That's the equivalent of 15 billion years. Never mind where you're going to put all that water you drain. Didn't think about that part, did you? Now, we as human beings have faced all sorts of challenges. Ice ages, tough diseases, squabbles over real estate, and so on. But let's try to go way back to 400 million years ago, to the times when our oceans were ruled by sea creatures and the lands barely had any animals on them. Do you think you'd be able to survive there? We're talking about the Devonian period. It started around 400 million years ago and lasted really long, about 60 million years. It's named after Devon, England, where scientists first studied rocks from this time. The world was quite different then. Our planet featured 3 continents, a gigantic supercontinent, Gondwana, down south, a smaller one called Siberia up north, and another medium-sized one called Laurasia to the east. These landmasses were moving around and crashing into each other, making big mountains. Now, imagine if your time machine broke down and you ended up in this ancient world. You're now in a world where the land is pretty much a barren wasteland. You are surrounded by basic plants like mosses and ferns. This is the early Devonian period. There were no trees yet, but moss was everywhere. And wow, that's a lot of water. Around 85% of the Earth was covered by oceans during the Devonian. So you see many warm, shallow, oxygen-depleted lakes around you. The first thing you notice is that breathing seems a little harder. Well, don't panic. It's all because of lower oxygen levels, around 19%. It's still enough to ignite fire, and trust me, you'll need one, but prepare to feel a bit dizzy. Luckily, there are no huge predators to run away from, but you'll probably have to do a lot of swimming. Alright, at least the weather seems pretty nice, warm and steady. If you keep traveling, you'll notice that the land seems almost limitless. That's because we're on Gondwana, the biggest supercontinent of them all. Since the tectonic plates don't move around much, there are barely any mountains around, and the Earth actually feels flat. Well, not totally flat. Gondwana boasted a gigantic mountain range, akin to the Himalayas. This range was gradually breaking down, sending sediments into the ocean. Those sediments would provide nutrients that help marine life thrive. In any case, it really feels like a whole different planet. The landscape around you looks like something out of Mars, if it had water. The only question is, where is all the life? Underwater, of course. There's a reason why Devonian is called the Age of Fishes. Now, to be fair, it wasn't all fish. The conditions were perfect for certain early marine life to develop important things, like lungs. Some even gained the ability to crawl out of the water and onto land for short periods. So, if you spot a tiny lizard-like creature around the coast, don't step on it. It's your great-great-great-great-grandparent. Well, it's not like you'd be able to really step on it. Remember the guy from the evolution meme with a funny crocodile-like head? His name is Tiktaalik. As you can guess, it was one of the first creatures linking fish to land. And although it might look friendly, it actually has a 9-foot-long body and very sharp teeth. And yes, it can crawl. So if you notice a huge lizard, better find a hiding spot. You'll start seeing more of those Tiktaaliks and four-legged animals in general by the Middle Devonian. But let's risk our lives for a moment and dive underwater. What do we have here? Welcome to Subnautica, Earth Virgin. While the land looks very primitive, marine life is incredibly diverse. We have corals, sponge-like creatures, sea lilies, shellfish that resemble clams, and more. The oceans are filled with various critters that look fascinating and potentially dangerous. Here are some tough armored placoderms, and yes, all of them are bigger than you. These formidable fish had powerful jaws with blade-like plates as teeth. They started as tiny guys who munched on mollusks, but as time went on, some turned into massive fish-slicing monsters, reaching up to 33 feet in length. The biggest of them was Heterosteus with their scary-looking eyes. This other guy, whose name Titanichthys, with its mouth always ready to swallow you. And the largest one, Dunkleosteus. Oh, those are $5 names, huh? And here are some smaller guys. These are the shark ancestors, the cartilaginous fish. They had small, rough scales, fixed fins, and sharp, replaceable teeth. And finally, there are tiny ancestors of our normal modern sea creatures, bony fish. They're nice and pretty harmless. They were covered in scales and equipped with maneuverable fins. You know what? I think you can cook this one. So the question is, how do you cook it? There are no trees for fuel around, not until the Middle Devonian at least. So you'd have to scrounge up some super dry moss and get to work rubbing rocks together. Fortunately, the warmth of the climate would save you from freezing at night. But since there's not much stuff to burn, you might be better off sticking to a raw diet of mollusks and other early arthropods. In this world of basic plant life on land and a huge ocean around, getting food and resources would be quite tough for you. Perhaps you could stick to fishing or collecting stuff from the sea. Overall, you'd have to be really clever to live off the small amount of plant life and maybe learn a thing or two from the sea creatures about navigating the oceans. In any case, you'd have to start from scratch. Surviving in the Devonian would be quite a challenge. Our bodies aren't built for living underwater or thriving in an environment dominated by early marine life. You need some shelter. Maybe you could try to build a basic house along the shores using dirt and moss, probably. You just need to create tools and shelters using whatever resources you can find. So, get creative. Also, get used to living without clothes, unless you make up a way to create a dress out of moss, seashells, and fish bones, all Little Mermaid style. Alright, to make it more fair for you, let's say you ended up closer to the late Devonian period. Hey, now things are looking up. At the end of that era, the first forests started covering our Earth. Now we had plants with spores, leaves and roots, and even the first plants with seeds. The land is slowly getting some life. Hooray to normal breathing again! We've got some little bugs, 4- and 6-legged critters. The first land vertebrates, early tetrapods, started showing up. They're pretty cool. Very early ancestors of mammals and eventually us humans. But hold on, Houston, we've got a problem. As plants started taking over the land and breaking the rocks with roots, they released tons of nutrients in the water and caused a chain reaction. The sea got filled with algae, greedy bacteria thrived, and since there was almost no oxygen in the waters, around 70 to 80% of the species vanished. Whoops. But hey, good news for you! Less oxygen-hungry predators in the water. However, now you have to watch out for your new land neighbors. Most of them aren't harmful, but it's better to watch out. But still, with more trees and plants around, you could make useful tools like spears, fishing hooks, and rope. During the end of the Devonian, you might even build yourself a tree house. Picture that, in a world with the first tree ever, reaching 90 feet tall with a super wide trunk. So, it seems like you'd be able to survive without much trouble. You might even turn into a vegetarian with all these plant options. And hey, no more itchy clothes. You could fashion something much more comfortable. And remember that dinosaurs are on their way. Until then, enjoy your time. If people had feathers, wolverine claws, long beaks, sharp teeth, and other features of animals, it wouldn't change our lives globally. We would pay more for manicure services, or wouldn't need knives, using our sharp claws instead. The culture of food consumption would change if we had long beaks. Feather care would create new branches in the field of fashion and self-care. All these things help animals survive in the wild, but they would be pointless for us. But what would change our lives completely would be a drop in our blood temperature. The circulation of cold fluids in our bodies would change our lifestyle and open up opportunities for physiological changes. The coolest thing is that the number of bacteria in our organisms would decrease significantly. Our warm bodies maintain the ideal temperature for both good and bad bacteria. But if we become cold, most microbes won't survive. They won't be able to reproduce, and we will go to the doctor less often. But there's a downside. Those rare microbes that can adapt to low temperatures would cause serious health problems. The fact is that cold blood can slow down your immune system. Protective cells will fight less effectively against unwelcome little guests. Another problem with cold-blooded people, they would depend on external conditions. We warm-blooded creatures can't live at extreme temperatures either, but our organisms can react to any changes and regulate the state of the body. For example, when we're hot, we sweat, and thus cool ourselves. When we feel cold, our muscles tense up, we start shaking, and the blood circulates faster in the vessels to warm us up. These features help to adapt to the cold and heat. But if we were cold-blooded, we'd lose the possibility of this regulation. We would be too sensitive to any temperature changes. Imagine all those reptiles living in home terrariums. Their owners buy expensive lamps to heat their homes. Our houses would look the same. With cold blood inside, we wouldn't become more resistant to the cold. We would become more dependent on warm conditions. We would waste a huge amount of energy on additional heaters and gas stoves. And during cold weather, we would spend all our money on heat. But our financial situation would remain the same because we would spend less money on food. Warm-blooded creatures use a lot of energy to maintain the high temperatures of their bodies, and they take this energy from food. Therefore, cold-blooded people would eat much less, and they would also have a slow metabolism. A hearty breakfast in the morning would be enough to function normally all day. However, not everyone can spend a lot of money on electricity. In cold regions, people would have to keep heaters on almost all year round. It would be much cheaper to move closer to the equator and not waste money on electricity at all. Almost all cold-blooded people would strive to live there. The northern parts of the planet would get empty, but in the southern regions, overpopulation would begin. A considerable number of people wouldn't be able to live comfortably on such small territories. The construction of hundreds of thousands of buildings, millions of cars with exhaust gases, factories, and plants on the equator would significantly worsen the environmental situation. More population density would lead to disaster. But fortunately, the coldness of our bodies would help us with this problem. You know that bears hibernate. These warm-blooded animals put on a lot of fat and then go to their den to sleep through the winter. And at this time, their body feeds on the accumulated fat. However, cold-blooded creatures are also capable of this. And unlike bears, they don't need to stock up on extra calories as they have much lower energy needs. Turtles and frogs can burrow into the silt under lakes and ponds and spend up to 6 months there. The liquid inside their bodies freezes, but the cells remain alive. This allows them to go through difficult times easily. So, this ability would ideally help people reduce the load on the planet. Going to the equator is unnecessary if you can spend 6 months of winter in your bed. And people living on the equator could take turns doing it. Have you slept for 6 months? Great, now it's my turn. Of course, this would significantly change the planet's economy. Production capacity would drop. There would be fewer goods and services in the world. There would be fewer taxis in cities and fewer restaurants. But it would reduce the harm caused to the environment. Imagine how easy it would be to wait for the release of some movie or video game. And what would happen to our dreams? Flying in the clouds for 6 months, or speaking with a group of mutant seagulls on another planet would be cool. Lucid dreaming training centers would be opening all over the world so that you could have fun during hibernation. But not all people would agree to such conditions. Imagine training hard, keeping a strict diet, and then just losing 6 months of your life. All your progress would disappear, and you'd have to start from the beginning. Interestingly, there would be fewer athletes in such a world. Another superpower of cold-blooded people would be the ability to live underwater. Dolphins, whales, seals, and other mammals live in seas and oceans. But for some reason, evolution hasn't given them gills. They can't extract oxygen from the water like fish, so they have to swim to the surface many times per day. The reason for this is their warm-bloodedness. Cold-blooded fish don't need a lot of oxygen. They extract a small part of it from the water with the help of gills, and it's enough for them. But this wouldn't be enough for warm-blooded creatures. If dolphins had gills, they would be huge, since dolphins need 15 times more oxygen per pound of their mass than cold-blooded fish. Gills need to constantly move large amounts of water to extract oxygen. Sharks must always be in motion to get the necessary supply. Now, if humans had gills, they would be gigantic, and we would have to swim very fast to get enough oxygen. But everything would be much easier if people were cold-blooded. Perhaps if we started living in the water, then evolution would give us gills in a couple of thousand years. We would have a better chance of regenerating with a low body temperature. Cold-blooded starfish, lizards, and salamanders can grow limbs and organs and even completely restore their entire body systems. With such a superpower, we would be able to defeat aging, save millions on doctor's visits, and avoid surgeries. But would we be able to fly if cold blood flowed in our veins? Unfortunately, we wouldn't be able to grow wings. A bird is a warm-blooded creature with a fast metabolism. It needs a lot of oxygen and energy to fly. If people in some parallel universe could fly, their bones would be much lighter and more fragile, and their muscles would be more developed. Even with these anatomical changes, they wouldn't be able to fly freely like pigeons or sparrows. Flying people would be clumsy and barely maneuverable in the air. They would need to learn how to absorb more oxygen in flight. Otherwise, they would fly with oxygen tanks. Or probably evolution would make their lungs much bigger. Despite many pros, cold blood is still a disadvantage. Perhaps our brain wouldn't be as developed since it would need less energy. So it's good that our blood is warm. We don't have gills, but we cross oceans on ships. We don't regenerate fast, but we have advanced medicine. We have a fast metabolism, and there's a lot of delicious food in the supermarket. We now have the ideal body structure for a comfortable existence in this world. But how would our life change if our body temperature rose 2 times? Well, that's a story for another video. Hey, watch this space.